Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to sign up via the link in the description to get all of the lab files for this course, so you can try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better, and it includes all of these guided labs to not only help you get hands-on practice configuring and troubleshooting, but also deepen your understanding of the exam topics. I used it myself when studying for my certifications, so I feel confident about recommending it to all of you. If you want to get your own copy of NetSim, please follow the link in the video description. In this lab, we will configure a couple extended ACLs to fulfill the network policies listed here. Hosts in 172.16.2.0/24 can't communicate with PC1. Hosts in 172.16.1.0/24 can't access the DNS service on server 1. DNS is something we will cover later in the course, but even if you don't totally understand the protocol yet, you can use extended ACLs to block it. The third requirement is that hosts in 172.16.2.0/24 can't access the HTTP or HTTPS services on server 2. As you probably know by now, HTTP and HTTPS are used to access web pages. As I have said a few times, ACL configuration is flexible and there are often multiple valid solutions. In this video, I'll show you my solution. I will configure two ACLs on R1, one to fulfill the first and third requirements, and then another to fulfill the second requirement. I'll start with the second requirement. Hosts in 172.16.1.0/24 can't access the DNS service on server 1. First, let me briefly show how DNS works. I'll go on PC1. Then open the Config tab, and you can see that I have specified 192.168.1.100 server 1 as PC1's DNS server. DNS, domain name system, lets you specify names instead of IP addresses as destinations. Let me show an example. Go to desktop, then command prompt. Let's try a ping to PC2. However, instead of pinging PC2's IP address, I'll specify the name PC2. Ping PC2. Now this ping will take a little longer than usual. Currently, PC1 is contacting server 1 to learn what the IP address of PC2 is. Although using names like google.com or youtube.com is easier than remembering IP addresses for us humans, the computers themselves still need to know the IP address. That's what DNS is for. DNS servers contain a list of names and IP addresses. As you can see, although I specified ping PC2, PC1 asks server 1 what the IP address of PC2 is, and learned that it is 172.16.1.2, as is displayed here. Okay, we'll cover DNS later. Now let's go on R1 and configure that ACL. Enable, conft. I'll configure a numbered ACL. IP access list extended 100. So let's deny DNS. Deny. Now which protocol should we deny? If you remember correctly, DNS uses both TCP and UDP. Usually, UDP is used. However, there are cases where TCP is used too. So let's block both. I'll create an entry for UDP first. Then the source IP, 172.16.1.0, 0.0.0.255. We don't need to specify the source port, so next is the destination IP. Host 192.168.1.100. And finally, the port number. Do you remember DNS's port number? It's 53, so EQ 53. Okay, now I'll use the up arrow and just change UDP to TCP. There's the second entry. Finally, I'll configure permit IP any to allow other traffic. Now let's apply the ACL. Following the rule of applying it close to the source, I'll apply it inbound on G00. Interface G00. IP access group 100 in. Okay, we have created and applied the ACL. Let's see if it works. I'll return to PC1. Let's try to ping server 2 this time. I'll try to ping it by name. Ping server 2. Now, PC1 shouldn't be able to learn server 2's IP address. I'll click on this arrow to skip forward 30 seconds in Packet Tracer, and now when I return to PC1, you can see that it could not find host server 2. So PC1 wasn't able to access the DNS service on server 1 to learn server 2's IP address. How about if I just ping server 2's IP address? Ping 192.168.2.100. As usual, the first 1 or 2 might fail because the ARP process is a little slow in Packet Tracer, but then the ping succeeds. Okay, so we have fulfilled the second requirement. Now let's make an ACL for the first and third requirements. They both have the same source, 172.16.2.0/24, so I'll combine them into one ACL. IP Access List Extended 101. So that first requirement is a simple deny statement for destination PC1. Deny IP 172.16.2.0, 0.0.0.255, host 172.16.1.1. That's it. We're denying all traffic, so I used IP as the protocol. Now let's prevent this subnet from using the HTTP or HTTPS services on server 2. First, let me go on PC3 and show you a website. I configured an entry for Cisco.com on the DNS server, server 1. So if I use the web browser here on PC3 and type the URL cisco.com, PC3 should learn server 2's IP address and be able to access the web page. It's just a sample web page, which is in Packet Tracer by default. After we configure and apply the ACL, we shouldn't be able to access this web page. Now I'll return to R1. Let's deny HTTP and HTTPS. Deny TCP, because both HTTP and HTTPS use TCP. Then the source IP, 172.16.2.0, 0.0.0.255. Then the destination IP, host 192.168.2.100. Finally, I'll specify HTTP, EQ80. And I'll add another entry and change the port number to 443 for HTTPS. Finally, let's permit all other traffic. Permit IP any. Now let's apply it close to the source. Inbound on G01 is best. Interface G01. IP access group 101 in. Okay, let's try to access that web page again. I'll return to PC3. First, I'll close the web browser and open it again. Now let's try to access Cisco.com. No web page appears. PC3 is being blocked by the ACL we configured on R1, and the request times out. Now, how about the first requirement? Let's go to the command prompt here on PC3 and try to ping PC1. This subnet is still able to use the DNS service on server 1, so I'll try to ping it by name. Ping PC1. However, the ACL we just configured on R1 prevents PC3 from pinging PC1, but a ping to PC2 should work. Ping PC2. Wait a bit for PC3 to learn PC2's IP address from server 1, and then the ping is successful. So, we have satisfied all requirements. Finally, let's just view the ACLs. Let me return to R1, and I'll check. Do show access lists. There they are, and you can see the number of matches for each entry of each ACL. That's all for this lab. Next, let's take a look at a lab in Boson NetSim for CCNA. Okay, here's today's Boson NetSim lab preview. As I said before, there are 20 ACL practice labs in NetSim. So if you want lots of practice configuring and troubleshooting ACLs, NetSim is a great tool. Here is the lab topology. It's the same as the demo I showed you in day 34, with router 1 and router 2, and then PC 1, 2, and 3, each in their own VLAN. This time the command summary shows us the protocol as well as the port numbers. So these are extended ACLs, not standard ACLs. Here are the IP addresses on each device. Notice that router 2 is using router on a stick here, Fast Ethernet 10.2 and .3. because there are two VLANs here, two subnets connected to this single physical interface. And that will be important later, so remember that. Okay, and there is just a single task, but it's pretty long, 18 steps. So for today's demo, we will just complete up to step 7, which says on the appropriate device, apply extended ACL 101 to the correct interface in the correct direction. So we will create this ACL in step 6 and apply it in step 7. So let's quickly read that task. In this task, you will configure multiple extended ACLs to permit and deny traffic from various protocols and sources across the topology. You should use extended ACL best practices wherever possible, such as applying the ACL as close to the source as possible. When all tasks are complete, each PC should remain able to ping the address of the loopback interface on each router. However, as I said before, we are not going to complete all the tasks, just up to step 7. Pings to other destinations should succeed or fail per the instructions below. Okay, so let's get started. First, from each PC, verify that you can ping the loopback 0 interfaces of both router 1 and router 2. So I will open up a console connection to each of the PCs. And let's try those pings from PC 1. Okay, it works, and I'll try to ping router 2. Okay, and just for the sake of time, I'll skip PC 2. I know you don't want to watch me do a bunch of pings. Let's try PC 3. Okay, it can ping router 1 and router 2. I'm using Control-C, that's what this means, Control-C to stop the pings. After I get a reply, that means the ping is successful, so I just cut it off early. Okay, next from each PC, verify that you can ping every other PC in the topology. Okay, from PC 1, I'll ping PC 2, and it works. Stop that ping. And PC 3, that works as well. So because we were able to ping and get a reply, we have verified two-way connectivity between PC 1 and PC 2, and PC 1 and PC 3. So the only one we have to do is from PC 2 to PC 3. Okay, and we get a reply. So we have also verified two-way connectivity between PC 2 and PC 3. Next up, in steps 3, 4, and 5, we are going to attempt to telnet to router 1 and router 2 from different PCs. I showed you telnet briefly in the NetSim demo for day 34, and we will cover it more in depth later in the course. So first from PC 1 to router 2's loopback interface. Telnet 2.2.2.2. Okay, and because I get this password prompt to log in, that means the telnet was successful. I was able to connect to router 2 with telnet. I just have to enter the password to log in. And it works. It says up here, all passwords in this lab are configured to Boson. Okay, and the prompt is now router 2. I'll exit out of there. And then from PC 2 and PC 3, telnet to router 1. Okay, that works. And PC 3. Okay, great. So step 6. On the appropriate device, create extended ACL 101. The ACL should permit telnet traffic from PC 2 and PC 3 to router 1's loopback 0 interface. Limit the ACL you create to a single rule. Specify the port number, source wildcard mask, and destination wildcard mask. Okay, so a single rule, single entry ACL, which allows both PC2 and PC3 to telnet to this address, 1.1.1.1. So where should I create the ACL? What is the appropriate device? Well, these are extended ACLs we're making, so we should create and apply them as close to the source as possible. In this case, the source is PC2 and PC3, so that means we should create the ACL on router 2. Okay, I'll configure it right here from global config mode. Access list 101, permit. Now next is the protocol. Telnet uses TCP as its layer 4 protocol, so TCP. And next up, the source IP address, 10.10. And we want to include both PC2 and PC3. So both of these subnets, 10.10.2.102/24 and 10.10.3.103/24. So let me think about that. 10.10.2.0 and a /23 subnet mask should work. 0.0.1.255. Okay, and we don't have to specify the source port number. So next is the destination IP address, 1.1.1.1 with a /32 wildcard mask. Finally, the destination port. This is where we specify telnet. So EQ to specify a single port. And now I can either specify the keyword telnet or telnet's port number, which is 23. I'll use the keyword telnet. There we go. Okay, now here's the really tricky part. We have to apply it to the correct interface in the correct direction, as it says here. Apply extended ACL 101 to the correct interface in the correct direction. So the interface that is connected to switch 2, and therefore PC2 and PC3 is this one here, fast Ethernet 1.0. However, we cannot apply this ACL to the physical interface. That will not work. So we can either apply it inbound on both of these sub-interfaces, fast Ethernet 1/0.2, 1/0.3, or instead of doing that, if we want to apply it just to a single interface, we could also apply it outbound on this interface here. It's still pretty close to the source. Let's do that since it's simpler. We just have to apply it to a single interface. So I will apply it outbound on fast Ethernet 0.0. So when these two PCs try to telnet to router 1, the ACL will be checked when router 2 forwards the traffic out of its fast Ethernet 0.0 interface, which is here. It won't check it when it receives the traffic here on the fast Ethernet 0.1 interface. Or sorry, not 0.1, 1.0. Okay, so interface F00, IP access group 101, out. Okay, so let's try a ping from PC2 to router 1's loopback 0 interface. Okay, it's not working. Why is that? It's because our ACL only permits telnet from PC2 and PC3 to router 1's loopback interface. However, the ACL is just a single line. That means any traffic that isn't that telnet traffic will be denied by the implicit deny at the end of the ACL. So currently, PC2 and PC3 will not be able to ping router 1. The task description here said each PC should remain able to ping the address of the loopback interface on each router. So I assume later, in one of the later tasks, we would fix that. But let me just check that PC3 also can't ping router 1's loopback interface. Okay, it also doesn't work. Now how about telnet? Telnet should work. So I'll try to telnet from PC2 to router 1's loopback interface. And it works. Great. And how about PC3? Okay, it works also. And let's just take a look at that ACL in the running config of router 2. There it is. So we are permitting TCP traffic from this range of addresses here, 10.10.2.0/23, to host 1.1.1.1, destination port of 23 telnet. And all other traffic will be denied because of the implicit deny at the end of the ACL. Okay, so after that, there are many more tasks here, but we'll end today's lab demo here. And I will use Boson's grade lab function. Now, since we aren't done the lab, it says you missed one or more commands in the lab, but that's okay. I just want to check router 2's configuration. Did I get that correct? Oh, so I was right. So we did get that entry correct, permitting the telnet traffic, but probably later in this lab, in one of the later steps, looks like we add a permit ICMP any command to allow those pings. Okay, so that's Boson NetSim for CCNA. If you want to get Boson NetSim, please follow the link in the video description. As you can see here, there are tons of practice labs for the CCNA, all very in-depth, very good for testing your knowledge and improving your skills of configuring and troubleshooting. Once again, follow that link in the video description. Before finishing today's video, I want to thank my JCNP level channel members. To join, please click the Join button under the video. Thank you to Samil, Aaron, Junhong, Njabulo, Benjamin, Sepiso, Justin, Prakash, Nasir, Erloson, Apogee, Marco, Daming, Joshua, Gilmar, Ed, Value, John, Funny Dart, Velvejacum, C-Mode, Mark, Yusuf, Boson Software, Devin, Lito, Jonathan, and Vance. Sorry if I pronounced your name incorrectly, but thank you so much for your support. This is the list of JCNP level members at the time of recording, by the way, December 6th, 2020. If you signed up recently and your name isn't on here, don't worry. You'll be in future videos. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.